Hi, today we're going to start talking about measurement and how important it is that you are measuring accurately and what happens when we are measuring actual quantities in the real world rather than just thinking about numbers that are theoretical. And we're going to tie this back to what we were doing before Thanksgiving break and think about proportional relationships. And so I gave 9 squares, and to each team you had 3 squares that you were in charge of investigating. And I really want to figure out, are these quantities related to each other? And so the quantities that we were looking at first were the diagonal of that square, so going from one point to the opposite point, which in this case actually looks horizontal, but it is diagonal because it's an opposite. Down here you can see more clearly that it's a diagonal because you're going from one point to the opposite point. And compare that to the perimeter, which is the distance around a figure. And is that relationship proportional or not in squares? So as we kind of looked at this, we recognized there are some things about squares that we know. First off, like I just said, going from one point to the opposite point is going to give you the diagonal. It's going to be the same no matter which way you go, so you could measure either of these distances and they should be the same. And then because all of the side lengths are the same, you could add them up and do 4 plus 4 plus 4 plus 4, but you could also do 4 times 4 and do measure one side length and then multiply it by 4, which is a little bit more efficient. So that's what several teams did to increase their efficiency. And when we aggregated our class data, we ended up with these. So looking at this, it's not clear to me right away whether this is proportional or not. I can't quite see what I would be multiplying the diagonals number by to get the perimeter's value. So it's helpful to graph because we already know some things about what proportional graphs look like. So we can see, kind of get a gut feeling, an intuition of whether this is proportional or not by looking at a graph. So we took all of these and we plotted them onto a graph. We ended up with something that looks like this, which I gotta say is pretty dang close to a straight line through the origin. Now it's not exact, but if I took a ruler and started at the origin and kind of plotted like this, I'm pretty close. I have some things that look like they're a little bit high, some things that maybe look like they're a little bit low, but that really could just be measurement error. And it's hard to be incredibly precise when you're measuring with a ruler like this, because sometimes you can't decide, is it at 1.1 or is it 1.2? And those two numbers are going to look different than when you plot them, and that means that being close enough is good enough. So this is close enough to being a straight line through the origin. These points basically lie on a straight line. Through that origin, 0, 0. So that tells me that it is probably proportional because it's really close. And I think we can say measuring error is what caused those slight discrepancies. So we have tiny discrepancies, but it's close enough. It's good enough with this data. So I can say this is proportional. What's more, I could figure out now what an approximate constant of proportionality would be, since I feel pretty convinced that it is proportional. So to look at that, I want to see what would I need to multiply to get from the diagonal to the perimeter. So let's look at the relationship between the perimeter and the diagonal. So P divided by D. Well, 16 divided by 5.7, that's approximately, though not quite, 3. So if we wanted to be a little bit more precise, we would say that's 16 divided by 5.7, that's about 2.8. 24 divided by 8.5, that's about 2.8. 10 divided by 3.5 is about 2.9. It's 2.85, so I would round that to 9. 12 divided by 4.2 is about 2.85, 2.9. and so on and so forth. And looking at this, I'm going to see that they all hover around that. So if I wanted to, I don't know, kind of take the average, maybe I could say the constant of proportionality is about 2.85. And if I multiply my diagonal by 2.85 or 2.8 or 2.9, considering the level of precision that we can get, then I'm going to get everything in my perimeter. And this is going to be helpful for you as you're looking at the homework tonight, thinking about this constant of proportionality. Let's label that COP. So 7C, we looked at the area. 7B and 7A, I decided that it was more important for us to really think kind of deeply about the summary questions and then get a chance to think a little bit about the homework before leaving. But what 7C noticed when they did this was that you ended up with a graph that looked more like this. The points were going like that. So even though you had some points that were in different places, this, if you were to try to kind of connect those dots, that's really clearly not going to make a line. It's pretty clearly curved, and I don't think that measurement error could be so bad that we would end up with something that looks like this. So I would tell myself then that this is not going to be proportional, because you do not have that straight line that's going through the origin. So with the same thing, with these squares, you can end up with some proportional relationships and some non-proportional relationships. And it actually relates to what we talked about way back in the day with scaling, that area is not proportional to length in the same way that length would be proportional to length. So looking at the diagonal to the perimeter, that is proportional. Looking at the diagonal to the area, that is not proportional. And we could tell because it was basically a line, and this one was more of a curve. So if we've got a graph, you already have these tools from before break. It's going to be a proportional relationship if it looks like a line that is going through the origin, 0, 0. And measurement error is important because it should be close. Measurement error means it may not exactly look like a line. If you have something that looks like that, then it's quite probably proportional, and we just have some discrepancies with these measurements. If you have something that looks like that, on the other hand, there's really no way that your measurements could be that bad. I don't see any way to get a line out of this, so I would say that is not proportional. To put that to work right away, looking at our CFU, we've got the relationship between time that's passed and our plant heights. And as I look at this, I can trace a pretty good line through that. Sorry, it's a little bit hard to see, but I can trace a line there. I could believe that this could be proportional. And I might even say probably is. And there was just some discrepancies in these measurements. This, on the other hand, if I try to trace that through, this line doesn't match up with that line. This is doing something completely different. There's really no way that I can make a line through that is true to any of the pieces of this data set. So I would say that this is definitely not, because there is really no error that should be so big that you would end up with something that looks this wavy. Okay. Tomorrow we're going to start talking about circles.